Lesson 19.1, Task 2. Calculate theoretical binomial probabilities. A binomial experiment is a probability experiment with n identical independent trials where there are only two possible outcomes, success or failure. Which result is deemed the success depends on the experimental result of interest. Designating the probability of success as P and the probability of failure as Q, the sum P plus Q will always equal 1. For example, when flipping a fair coin, it will lead to either heads or tails. Since the coin is fair, the two possibilities are equally likely. So the probability of getting heads is 1/2 and the probability of getting tails is 1/2. 1/2 plus 1/2 equals 1. So that's why they're saying P plus Q, success plus failure, equals 1, okay, which is 100% of your experiment. All right, so consider the binomial experiment of flipping a fair coin 5 times. What is the probability that exactly 3 of the 5 coin flips will be heads? All right, so we're going to look at Pascal's triangle again. So we have rows 0 through 5 of Pascal's triangle are shown with moves to the left representing results of tails and moves to the right represents the results of heads. So you can see here it goes tails and heads. This one goes tails and heads. This one represents tails and heads. So this one would be tails and heads, tails and heads, tails and heads, and so on. All right, so the number of ways of 3 heads to occur in 5 flips is modeled by the path that are combinations of 5 total moves, with 3 of those moves being to the right. All right, so when I look at this, I think of combinations, which what we looked at in the last case, and I think of what row and what position we need to look in. So in my mind, we're going to do 5 rows and position 3. So I would go 1, 2, 3, 4, 5, position 3. We'd have 0, 1, 2, 3 would be a 10. So in my mind, there's the combination there. 2 of the combinations are head, 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 tails, tails, and tails, tails, head, head, head. So give 2 other combinations. All right, so what they want you to say is like there's multiple paths to use. So if you come down through here, what way can you go in order to get to this same path? So basically they're saying how many different combinations are there to get. So there's multiple ones. So here's a sample of 2 other ones. You could do head, tails, heads, tails, heads. And you could do heads, heads, tails, tails, heads. Yes, all 4 paths end up at the same node. There are 10 different combinations, so 10 different ways to get 5 moves in which 3 of the moves are to the right for the coin flipping situation. These paths represent the 10 different ways to get exactly 3 heads when flipping a coin 5 times. So again, there's 10 different combinations there. So this again is just 2 examples. The other 2 here makes 4, and that means there are 6 other combinations that you could have come up with as well. Okay, now I would like to look at just the formula instead. So it says, how is the number of ways of getting 3 heads in 5 flips represented in NCR notation? All right, so that would be the 5 combination of 3. So the 5th row, the 3rd position. So let's do 5, math, probability of NCR, and then 3, and that gives you the 10. So the answer here is going to be 5 combination of 3. That's the notation that you want to use, and that's the easiest way to find these, either using Pascal's triangle or your calculator. All right, so it says the binomial probability of exactly R success in N trials is P of R equals, all right, NCR. So we're going to have our combination here, times, remember from above it said P represents success, okay, and R is the row, and then times Q is our failure, okay. If you remember, come all the way back to the top where it designated, it says P is the probability, oh wait a minute, depending on probability of success as P and the probability of failure as Q. So P success, Q is failure. All right, so we're talking about still getting heads 3 times when you flip a coin 5 times. So how would we use this to do that? So this is success of 3 times, and we want failure of 2 times because there's 5 total flips. So if success is 3, the remaining would be 2. So the N minus R, the 5 minus 3 would end up being a 2 here. All right, so the probability of getting 3 heads out of 5 coin tosses is the probability of getting exactly 3 heads when flipping the coin 5 times. P of 3 equals this, okay, so 5 combination of 3 times, remember this is success, so remember to be successful, to get heads is 1/2, and we want to do that to the 3rd power, and then failures would be 1/2 to the 2nd power. Because again, the 3 plus 5, when you add exponents, we need to get a 5 there. So 5 total coin tosses. So P of 3 would equal I believe this is 5/16, but let's check that using our calculator. All right, so if we want to do this formula here, we're going to do 5C3. So we're going to do 5 combination of 3, and then we're going to do times, so we're going to take that answer, and we're going to do times 1/2 to the 3rd power. 1/2 raised to the 3rd power, all right, and we're going to have that number, and we're going to multiply that times 1/2 squared. And then we can say, okay, does that equal 5/16? So if we have a decimal, you can change that to a fraction by going math, fraction, 5/16. So if you take this and just simplify it, okay, use order of operations, make sure you do that, you will see that that is 5/16. They show the math also down here and how to get that 5/16. All right, that's all for task 2. If you have any questions, let me know.